Welcome. Tonight's notes are going to be on fractional exponents. So, fractional exponents, and we are on page 45. So, first off, we're going to be doing some calculator stuff. So, in a calculator, let's go ahead and put 64 to the 1/2 and 8 to the 1/3, 36 to the 1/2, and 64 to the 1/3. Okay, so if you have a calculator, go ahead and do that. Put those four in your calculator and see what you get. So I'm going to go ahead and do it now. 64 to the 1/2. We get 8. 8 to the 1/3. 2. 36 to the 1/2. 6. And 64 to the 1/3. 4. Okay? So now I'm going to ask you a question. My question is, what does the 1/2 power represent? So that's my question. What does the 1/2 power represent? Well, looking at this, 64 to the 1/2 is 8. 36 to the 1/2 was 6. Do you notice a relationship between 64 and 8, 36 and 6? Hopefully you can see that those are the square roots. So, x to the 1/2 actually just means the square root of x. Okay, so you're actually just square rooting it when you're taking to the 1/2 power. Now, when you're square rooting something, we don't have a number out here. That's because if there's no number, it's an imaginary 2. So for right now, I'm going to put a little 2 there. So I know that's the square root. Even though if we don't have it, we know it's the square root anyways. Okay? Now my next question is, what does the 1/3 power represent? So we have 8 to the 1/3 is 2, 64 to the 1/3 is 4. So that would mean x to the 1/3 would be, what do you think that's going to be? That's going to be the cube root of x. The cube root is something times itself 3 times, gives us that number. 4 times itself gives us that 64. That's the cube root. Okay? So that's just an introduction. Now moving on, let's look at an example. Let's say we have x to the y over z. Okay? So we have a base and then we have a fractional exponent. We know we're going to write it somehow like this because that's what I just showed you. The y, the top number, the numerator, that's going to be the power of the base. And what does that mean? Well, inside of our square root, we're going to have our base, which is x. And then that y goes inside with the base. And then the z, that is whatever root we're working with. So the z goes out there. Just like that 2 is right there, just like that 3 is right there, that z is on the outside. Okay? So, how do we use this? Well, we use this when we have problems like this next example. 25 to the 3 over 2. Okay? 25 to the 3/2. Now, you cannot just plug it in the calculator. You must show work. So I'm going to write this down. Cannot just use a calculator must show work. If you get a problem that has anything like that in it, you have to show work to show how you got your answer. You can check your answer in that calculator, but you cannot just use the calculator, okay? So we're going to rewrite this using this method right here. So we're going to have the root, and our base is 25. So we have a 3 over 2. Which one of those goes inside with the base? Is it going to be the 3 or is it going to be the 2? It's going to be the 3. The 3 goes on the inside, and then that 2 goes on the outside. So we have the square root of 25 to the 3rd power. From there, we're going to break it down. And this says 25 to the 3rd, which means we're going to write it 3 times. So that's the square root 25 times 25 times 25. 3 times. Well, now I can break that up into the square root of 25 times the square root of 25 times the square root of 25. Do I need to write those 2's right here? No, right? Because if there's nothing there, we know it's a square root, but I just wrote those so that we could see it. And we know what the square root of 25 is. What is the square root of 25? That would be 5 times 5 times 5, because square root, which will give us an answer of 125. Okay? So that's how we break it down using that rule. I want you to go ahead and do this next problem. The video will stop. You'll put your answer in, and then I will go over it after. 64 to the 2/3. Okay? Go ahead and set that one up and do it. So when I set this up, we're going to get our root. Our base is 64. And then our top number goes inside. Our bottom number is that root right here. Now I'm going to break that up into the cube root of 64 times 64, because I have it twice. That's going to be the cube root of 64 times the cube root of 64. Now, do I know the cube root of 64? I'm not sure. So this is one of those instances that I am going to use my calculator just to check if I know the cube root of 64. Where you go is you press math, and you go down to right there. That has the cube root, 64, and you can see that it is 4. So that's going to be 4 times 4, which is 16. Okay? And then to check your work, we can plug this right into our calculator. 64 to the 2/3, and you can see that it is 16. You cannot just start by plugging that in the calculator. You must show your work, and then you can check it at the end. Okay? Thanks for watching.